So today our topic is about false position method. So false position method is an algorithm for finding a root which retains that the prior estimate for which the function value has opposite sign from the function value at the current best estimate of the root. So we have a formula for finding a root in the false position method. It is the x of n is equals to x of l times f of x of u minus x of u times f of x of l over f of x of u minus f of x of l. So let's have an example. So according to its meaning that the function for which function value has opposite sign. Then in our example, consider finding the root of f of x equals to x squared minus 3 and start with the interval 1 and 2. So when we substitute the 1 and 2 to the equation or to the function, we will have a value has an opposite sign. Let's check it out. So 1 for the value at x of l and 2, then 1 times 1 squared minus 3 is equals to negative 2. Then 2 squared minus 3 is equals to 1. So as we can see here, we have a value has opposite sign. So it means that the interval that given to this problem lies between here. The roots lies between 1 or 2. So again, when we substitute and when we put these values to the equation, so 1 times 1 minus 2 times negative 2 over 1 minus negative 2, since it is in a formula, we have a new value of 1.667. Then when we substitute this value to the equation, we have a value for negative 0.021. Then x of n minus x of l, 1.667 minus 1 is equals to 0.667. Then since, as I said earlier in the bisection method, that if the value x of n is negative, so we will change the value of x of l. So the value x of l will become the value of x sub n. So when it becomes positive, we will change the value of x of u. It will become the value here of the x of n. So since it's negative, the new value of x of l is 1.667. Then when we substitute the value of x sub l to the equation, we have negative 0.021. Then the x of u, copy the x of u, and we have here 1. Then again, using the formula x of l x of u minus x of u over x of l, we will get a value of positive 1.7273. Then again, when we substitute it to the value of the equation, we have value of negative 0.0164. Then when we minus the x of n minus x of l, we have 0.606. So let's put the value of 1.7273 in the x of l because we have a negative value of x of l. So 1.7273. Then copy the new value of x of l, which is 0.0164, and copy the x of u. Then f of x of u is equals to 1. Then when we use the formula again in getting the root, the only difference of false position method to the bisection is the formula, just the formula on how they solve the roots. And when we substitute the values to the formula, we have a value of x of m of 1.7317. And when we substitute it to the equation, we have a value of 0.0 0.012. And when we minus the x of n minus x of l is equal to 0.044. So, thus, the third iteration, we note that the last step, 1.7273 and 1.7317 is less than 0.01, as we can see here. In between here, it is less than 0.01. So therefore, we choose B, that equals to 1.7317 to be our approximation to the roots. And so after the three iteration, in the false position method, we have an acceptable value. We have an acceptable value in 1.7213, where f of 1.7313 is equals to 0.044, and it is less than 0.001. When we compare our result in false position and bisection, we can see that in false position, we find the approximation of the root in just 3 iterations. So I think it's better to use than the bisection method. So that's all. Thank you.